Need more range out of your Meshtastic LoRaWAN radio, or maybe your 900 MHz ham radio? Why not a Yagi antenna? This highly directional gain antenna, very easy to make. This is Dave in the shop. Stay tuned and I'll show you how. Today we're going to build this antenna. We're going to use this laser cut wooden boom and about 1 meter of copper wire, and we're going to use this little connector with a short stubby piece of coax. The Yagi antenna is highly directional. It lets you focus your radio's receive or transmit in a single direction. Typically you can expect a gain between 8 and 10 dB. That can help you receive weaker signals better or extend the transmit range for your radio. There's multiple options for making the boom. You can 3D print it, and I'll include a STL file in the show notes. You can also just take a piece of square 1/2 inch by 1/2 inch stock and drill it with 1/8 inch holes, or you can laser cut one. I'll include files and dimension drawing for all of this in the show notes. All right, the first step is let's take our copper wire and we will straighten it out. Get it fairly straight. Just a simple pull works pretty good. We don't have to be perfectly straight. We'll as we cut this apart, I'll show you a couple of tricks on how to really get it straight for the antenna. All right, we need to strip off the insulation. We'll use our utility knife and draw it through and pull off the insulation. Let's get the little part where we were holding it. Now that should just peel right off without any trouble. Excellent. Toss that in the trash. Okay, we've got our piece of wire. Now the key thing with this antenna, these elements, it's very important to measure very accurately. The frequency of the antenna is determined by the length of these elements, and each element needs to be cut to its precise length. Cut out of a piece of old scrap wood. I've got a template on here for my driven element that we'll make in a few minutes, and I got the lengths of all of the reflector and the directors for this antenna. So the rear longest element is the reflector, then I've got a driven element, and then I've got my directors, and that's what makes this antenna highly directional and have a lot of gain. All right, I'll supply a measured drawing that you can download, and the link to that will be in the show notes, and that will give you all the dimensions that you need to make these cuts. One of the things that I would like to ask you to do is to please like and subscribe to my channel, like the videos. That helps the YouTube algorithm get this content out in front of other like-minded people like us. So, all right, so let's start with the rear element, the reflector, and that needs to be 175 millimeters in length. I've had very good luck building this antenna and it be spot on frequency because measurements are very accurate. All right, now let's get our first director, which is 152 millimeters. We'll make that cut. And you can use, I like these cutters. These cut very square. They're shears. You can also use just standard dikes, but be aware that the ends will be a little bit sharper and you may need to do a little sanding to smooth them off. All right, now we're ready for our second director, which is 140 millimeters. Cut that. Hit our mark. Alright, and then we have one more director at that same length, 140 millimeters. And we'll cut that. Alright, we've cut our 4 elements. We've got our reflector and directors 1, 2, and 3. Now the next step is to go and make our driven element. This driven element is a folded feed element. It's a half wavelength element, and it's got this folded section that's used to match the impedance on the antenna. So as you can see from this little template, I had burned with my laser printer the profile, my laser cutter, excuse me, the profile of this element. The elements from the very back edge to the very tippy end is 158 millimeters, and then when you bend this, it's a tight bend. The outside edge to the outside edge should be 7 millimeters. That'll give you the right distance for this parallel section to be able to make the match. So we've got our remaining material, and what I like to do is cut this a little bit long, and then I'll trim it down after I do the bend. So let me just make a mark, giving myself about a 1/2 inch extra on the single side. Here's where my bend should be, and I'm going to use my round tipped needle nose pliers to make this very, very tight bend. Alright, so that looks pretty good. Now the other set of pliers I use is a square tipped pliers, and I use those just to make sure and straighten this wire, get this section nice and parallel. As you can see, that looks pretty good right there. Now the next step is let's cut the length. So I'm going to put it down on my template. In the show notes, I'll have a drawing that'll be a measured drawing of this template, so that you can match up your driven element. You can match it up to make sure all the lengths are just right. Just do me a favor, when you print that out, make sure, take a good ruler and measure what came out of the printer and make sure it's exactly right. Sometimes printers or the software will scale it a little bit. You want to make sure that you are getting the right measurements. Alright, so let's mark this. We'll mark the long side, which will be 158 millimeters, and then the short side, the parallel side, which is at the 82 millimeter mark. And we'll go ahead and cut those 2 pieces. All right, and there we have our driven element piece. Now the next thing to do, this is in pretty good shape, but take your time, make sure it's nice and parallel, make sure the distances are correct, and your antenna should then match up pretty well from the get-go. All right, now the thing that I need to do is take my feed line, and we're going to attach the feed line. We're going to solder it on. The key thing, this little piece of feed line, it is got a center conductor, and then it's got the shield, and there's just a little bit of the dielectric sticking out in between. So that's how these come from the factory. And what we're going to do is we are going to solder the center conductor to this short side, to the stub side, and we are going to solder the shield to the half-wave element side, and that'll be perpendicular. So let's get set up to do the soldering. To do our soldering, I've got my solder station set up here, and I've got a little vise to help hold this, make it a whole lot easier. So let me go ahead and put this piece in the vise, and then I'm going to use some soldering paste flux here to just put a little bit on here, and that'll just help it as we tin this with a little bit of solder. And let me make sure my soldering tip is good and clean. Alright, here we go. We'll start with the stub. Alright, that's got some solder on it. Now we're soldering on the half-wave long side of it. Get a little solder stuck there. Now we're ready to attach our coax. So I like to solder the center conductor on the end of the stub. Let's go ahead and heat that stub up. And as you can see, I'm soldering it right out on the end. Now that is soldered on, then this just holds in place all by itself. As long as I don't heat up that side of the stub, it'll stay put. And so the next step is, again, I'm putting my heat on the copper on the copper element, and then just build a little bit of buildup there. Okay, that's soldered in place. So shield is soldered onto the long side, center conductor soldered on here, and everything looks good. So there we have it. That should work just fine. Now, if you get too much solder on it, it might not slide into the boom all the way. So you can take a little file and just, very gently work and trim that, or you can use a Dremel tool with a little sanding disc on it, and that's what I'm going to do. I'm just going to clean that up just a little bit. On my safety glasses, and I'll run this fairly slow so it'll be really easy. So I'm concerned about the solder buildup on this side, because that's where it's going to slide into the boom. I don't have to worry about anything on the other side. So I'm just going to clean this up just a little bit. So that's cleaned up nicely, and let's just do a little test fit into the boom. So it is going to go into this second hole, the reflectors on the back, and then this will slide in, and I want it to slide in so that it's as close to the boom as possible. Alright, to straighten these elements, it's really simple. So I've got a piece of steel plate. This is 1/4 inch steel, flat surface. You could use the top of a table saw or a metal workbench. I would not do this on wood because it'll probably damage it. But all you have to do, I've got my little block here of plywood, is lay the element on here, and then you're just going to roll it between the two. This will get them nice and straight, and it also will work harden it just a little bit, so it'll make it a little bit stiffer. Antenna is mounted back in the vise. The elements are marked at the center point, and they're laid out here in order, longest to shortest, and then I've got my driven element. So now we're ready to glue these in place. So slide them in, get them centered up, and a little dab of hot glue. And then try to just keep them perpendicular to the boom as that glue sets. Ready for our driven element. A little hot glue there. Now we're going to first director. Second director. And then we're ready for the third director. Okay, that looks pretty good. Let's just touch up the glue. Make sure it's all the way around supporting the elements. Let that cool just a moment. And then what we'll do is flip this over, go in, put a little glue around it on the other side, then that'll hold them. Alright, that looks pretty good. Now we just need to let that cool. Then we'll be ready to hook the antenna up to the tiny network analyzer, the VNA, and check out the antenna and maybe make any final little tweaks to tune it. Alright, this is the NanoVNA. I'll put a link to it if you want to get one of these put a link in the show notes. They're not real expensive, and they are just awesome for checking antennas, checking coax and connectors and things, making sure that things are working the way that you expect them. And in this case, what we're going to do is we're going to look at the resonance of this antenna. So let me fire up the unit, and then I'm going to connect up. I've got a 3-foot length of high quality Teflon coax. I'm going to go ahead and connect up to this antenna. I've got a little barrel, SMA Barrel Connector in there to allow, it's a female to female barrel to allow the two pieces of coax to connect. And then I will connect this into the unit. Now I have pre-calibrated this unit. There's a simple procedure that you can go through to do the calibration. But it also has the ability to save settings. And it comes with a proper stylus, but hey, I use this pencil. And I'm going to use settings that I've saved before that's going to cause this to operate to frequency sweep this antenna from 400 megahertz to 1.2 gigahertz. And then we can see where the resonant point is on the antenna. Also, I've got my center marker on this set to 912 megahertz. So I'm building this particular antenna to use with Meshtastic, and the two common frequencies that we use in our area One of them is around 906 megahertz and the other one is around 913 megahertz. So I put a marker in here, and I don't know how well you can see that. Maybe I can get a little bit of close-up action with a different camera. And you can see my marker at 912. I think when I designed this particular antenna, I designed it for that lower frequency. As you can see, the bottom of it is just a little bit below, probably around 906, 905 megahertz. So right out of the box, the antenna is resonant where we want it. It's good enough. Now what I can do is play with the elements just a little bit to attempt to tune it in just a little bit higher. I could even sand off or maybe trim off just a little bit if I need to move it up in frequency a little bit more. Let me try to get this pointed away from metal. I'm going to move this over to kind of point into the workshop a little bit. Let's get our feed line kind of pulled out of the way. And I do have a metal vise here, so let me move this so that the metal vise is kind of out of the way as best as possible. All right, so we look pretty good there. Let's see if we can just make a little bit of adjustment on it. Oh yeah, what I did is I just bent this element in a little bit towards the driven element, and that loads this up just a little bit more, and it made a big difference. Okay, so the bottom on this is somewhere around 1.4 SWR, and so that's good enough. I mean, I could certainly play with it and do a little bending, a little tweaking, maybe a little sanding on the length of the element, just to make some tiny adjustments and wiggle the frequency up just a little bit. But this will work fine just like it is. So easy antenna to build. If you cut your elements accurately, then it's going to be pretty much spot on to frequency, and require just minor tweaking. So I can't wait to get this out and play with it, do a little bit of testing with my Meshtastic radio, and I'm sure this is going to work really, really well. Maybe in the future I'll do some videos where I do some home antenna range testing, where we can really compare the performance of this antenna with other known antennas, just so we can see just how good that it really does. This is Dave in the shop. I hope you enjoyed this build. I look forward to seeing you on future videos.